We're here from GRAPHISOFT Center Denmark. My name is Thomas Grabæk. I'm hosting this webinar about 3D and BIM-based detail and documentation. I'm here together with my colleague Thomas Nyman Jensen. Welcome.
Thank you.
Thanks for joining us also. And today we're gonna talk about how to go to the next level in the project workflow. Last time we had a webinar about sketching and early phase design, and this time it's about detailing. And these webinars are done together with the VELUX, and we're very happy to do this project development guide for VELUX. So that's the project that we're going to go through today. So I'm going to share my screen and we'll jump right into it. So once again, welcome to this webinar, BIM-based details and documentation. Today we're going to go through quite a lot of different subjects about why it makes sense to use BIM as a detailing workflow. So we're going to talk about what detailing is, a little bit about 3D printing, and then we're talking about collaboration, how several people can work together with the same project at the same time. A little bit about how you model in detail to get the biggest benefits from the 3D geometry and the data. And part of that is the BIM objects in the model, and we're going to go through how VELUX BIM objects work and some of the benefits from those. A little bit about quantity takeoff and how to present your BIM project in a clever way. And then hopefully we're almost used an hour, but we have to have time for questions in the end. So please feel free to use the chat to write questions, and we'll answer some of them directly in the chat. We have our colleague Alberte who's looking on all the questions, and some of them will be answered live in the end of the webinar. So just to zoom out a little bit, VELUX Project Development Guide is a guide that we're trying to develop right now. So it's a work in progress. It's a project that's been built in real life. And we try to remake the documentation so we can show the whole workflow from early sketching through detail and documentation using BIM as the main tool. And you can go to the website velux.com/project-development-guide and you can actually download the drawing material as you see the front page here. So that's all the CAD drawings or the BIM drawings in A3 format. But you can also download the original BIM file and an IFC and some DWG drawings and the complete package. We've been inspired by a house that's actually been built by VELUX back in 2009. It's done by Art Arkitekter and Espersen Consulting Engineers. And the real building has been used as inspiration. So we're trying to remake the drawing documentation, but we're also changing structures and materials so it will be made as a new project, complying to the Danish building codes and sustainability climate demands in Denmark right now. The whole project is done by us in ArchiCAD, so part of the project is to try to see how BIM can be the spine of the project, a place for all the knowledge and all the info in one place. And for that, we're gonna show the detailed part today. So why does it make sense to use a BIM tool? Some could argue that the BIM tool is not the optimal tool for sketching. Some would argue BIM is not the optimal tool for making detailed drawings. It's easier to do that in 2D CAD. It's easier to manipulate the project, perhaps. But BIM is a great structure for collecting data and knowledge and information. And the more data you add, the more value you get. So if you can also have the knowledge and the data and the info from the early phase, and from the detailing, and perhaps from the building side and the contractor, then you have all data in one place, and that really makes a lot of sense. Using BIM, you'll be able to design and choose your solutions based on all the information in the BIM project. It's easier to collaborate with different people on the same project because there's not a lot of files, there's only one file that is shared. It's easier to coordinate with other disciplines, so that could be between a landscape architect, building architect, and the different engineers, perhaps also interior design. And then when you have this coordination, when you have the 3D model, it will work as a virtual prototype. And that means we can mimic what will be happening on the building side, so we can reduce the amount of mistakes and problems that are very expensive on the building side and not nearly as expensive in 3D on a computer. And then the last thing is about adding value through data reuse. And that means if I can do a 3D model that will create my drawings, I can use the same 3D model that I suddenly have to do visualizing. I can use the same 3D model to do energy calculation or LCA calculation or wind analysis. And perhaps I can use it for other things as well. And one of those things would be 3D printing. So we're very lucky that TMP Architecture have helped us printing the project. So what we did was actually just to export the BIM project and almost press print. So what we saw last time in the sketching webinar was actually just pressing print because this was a volume study. With the model that we have done for this episode, it's a little bit more detailed. So it's from the detailed part of the workflow, and for that you need to make sure that the windows are not part of the model. And for this model 3D print, we also wanted to be able to look inside the building and see the room layout. So the model had to be cut in different pieces and printed in small pieces. So there's a little more work done to produce a 3D print, manual work by making the 3D files for 3D print in this detail level. This one is 1 to 100 scale. But if you compare it to what we used to do with models in cardboard or in wood or physical models done from scratch, the effort is much less because we already have all the data. We have the geometry, we have the 3D model in the BIM project. So I think the way to make sure you add value from a BIM project is to try to go through every way that you can reuse the model and the data for delivering more. So that's the first part of what I want to show about detailing. Now we want to go to a live demo. So Thomas, you have brought the whole project and
yes.
in. Wish you just share your screen.
As Thomas just mentioned, the whole point of the BIM model is to have everything in the same project file, in the same model, so we can withdraw all both the initial design phases, but also turn it over to the more detailed and complex documentation set within the same 3D model, because we have everything in the same place. So I will just briefly get a 3D overview of the project. So this is the project with some context as well. And from this 3D model, we can withdraw all the data needed. That could be the 2D drawings, it could be DVG files, it could be the print file for the 3D print that Thomas just showed us. It could be simulation for LCA and climate and so on, all in the same model. This project was done as a teamwork project. That means that we were multiple users that could work at the same time in the project. So I'm just going to open my teamwork palette to see if anybody else should be online at the moment in this project. I don't think so, but at least here I can see that I myself is online in this project, and I can see whoever has been participating in the project as well.
And just a small note for that. So I can see you're using a Windows computer, and when I'm joining the project, I'm using a Mac computer. So platforms doesn't have anything to say with the teamwork project. So you can work from home if you want to, or you can work from the office or from your own computer or whatever you want.
Yeah. The OS doesn't matter, of course the computer, someone just said, doesn't matter. You just need an internet connection, at least when you enter the project and when you will send your changes to the project. I'll also be able to send messages to the other participants. That could be relevant messages according to the project, of course, but I could type in whatever I'd like, naturally. I could actually select an object in the project, and I could say review selected element, and by default it will prompt me to add a recipient. That could be any of the other participants in the project. Write a comment, get a screenshot of the model, and send that message directly to the recipient within this teamwork palette. Then they will be able to simply select the objects right from my viewpoint that was added to the message, so they can move directly to the object and see what I'm actually talking about and what I am asking them to do or to review. So that is all happening online simultaneously at the same time. So when we need to get up to speed, more people can participate at the same time. But also, if we have different disciplines to take care of, we can do that simultaneously or whenever we like within the same project.
And the last thing about the teamwork and BIM Cloud is that it has multiple layers of backups. So there are backups if something blows up, but also if a person deletes something by mistake, you can roll back time and find whatever they deleted.
Yes, the default setting is actually the BIM Cloud will automatically create a snapshot of the entire project every 4 hours. So you can always roll it back to how it looked 4 hours ago. You can also create that backup schedule yourself and save local versions like every day or once every 24 hours, however you like to set it up yourself. I'm just going to close the teamwork palette and look into this project. So if I look at my gable here in the project, I'll just show you how it has been built. So here's my wall, if I'm able to select it. And I'll just see that solitarily, so I'm only looking at the wall right now. And the wall consists of different layers of building materials. So all my 3D building components in this BIM project has been constructed by building materials. Now the building materials have a large data set connected to them, so I can already start to simulate and calculate various takeoffs based on the materials. Now this wall naturally consists of multiple materials, and if I would like to edit those and look into the data set of those, I could go to my material editor. For building materials, it has already highlighted the material as part of my selection. So the highlighted building materials are those that are part of the wall that was already selected in a 3D view. So here we have gypsum fiberboard, we have wood insulation, plain white, that is the paint, vapor barrier, and so on. Slate cladding for the outside, and fiber cement board. Now, a data set for any of these building materials could be, or is in fact, first of all, the cut fill. That is how it will look when I cut through it. That will be on my plan drawing, which is actually a horizontal section through my BIM model. Naturally, it will also be shown on the vertical sections that we know from classic 2D drawing sets. In 3D, it has a surface connected to it that will give it the 3D appearance, and the surface could be connected of a color, various parameters as how it reacts to light, and a picture that could be used as a texture file. Then all the building materials, these are grayed out right now because I need to reserve these settings because I'm in a teamwork project. If I reserve it, nobody else can edit it while I'm at it. I'll not reserve them right now, I'll simply just show them even though they're grayed out. All the building materials have an intersection priority. So, and in this case, my slatting has a intersection priority of 940, and the value goes from 0 to 1000. And the point is that the stronger material will cut through the weaker material by default. So in that way, I can have the model create detailed junctions to a certain level of detail automatically throughout the entire 3D project. So if I'm looking at my gypsum fireboards, for instance, they have a intersection priority strength of 630. And if I look at anything else, the paint, for instance, it's a bit weaker, 320, the vapor barrier, 185. And this determines how the program will automatically create the connection between the materials when two building parts meet. As you can see in this case, I've only seen the wall, so something has already been cut out from the installation part of the wall, and that will be the wooden load-bearing structure, which is not turned on right now in this view, but you can see how the strength of the wooden structure has automatically cut through the installation because the wooden load-bearing structure is stronger than the insulation. Now, all these building materials have been combined into one composite. That means I don't have to create this wall by adding all the layers of building materials. They've all been connected in advance in a composite. So if I would look into my composite editor to see how this building part has been constructed, I could go to my composite editor and find the proper composite. I could also simply just right click on my building part, go to Edit Selected Composite Profile, and here I can see a list of composites in my project. The composite in question, the one that was selected in 3D model, is already selected, and I can see how it has been constructed. In this case, building materials are added as skins, the building materials that was just mentioned. They've been added as skins to this composite, and they've been given a thickness, and all in all I get the total thickness at the bottom here. So this is the thickness of my wall and all the building materials contained within this composite used for the outer wall.
And as you can see, there's also a vapor barrier. So even though it's really thin membranes, set to 1 millimeter, they're part of this composite. And that will actually be important on a later webinar when we start talking about the LCA calculations, that we need to have the CO2 footprint of every material. So every material must also be part of the 3D model.
And what can I use this intersection priority for and these different data sets of my building materials? Well, if I switch to a section that was set up in the project, and the section is created simply by adding a section line to my 3D model, and then the program will show me how it looks inside the model based on that section line. So here you can see the wall from my previous 3D view. I'm not going to change anything now, so here's the wall. Here is the roof, and you can see how they have automatically been connected because the roof actually extends all the way to the end of the cable, but there'll be some junctions that automatically appears within this corner based on the strength of the various building materials inside this connection. Now there might be multiple materials for insulation since they cut each other in different levels here. If I go to the bottom of the project, I can also see that my strip foundation down here automatically cuts through my terrain. Oh, there it is, my terrain slab. It has been cut out based on the strong concrete in the strip foundation.
You might want to zoom in a little bit so we better can see the connections. So this has not been drawn by 2D lines. This is an automated section.
Yes.
So everything is drawn directly from the model without any interference.
Exactly. The strip foundation right here is a 3D wall that serves the purpose as the strip foundation. It consists of various building materials combined in a profile, and because of the strength of these building materials, their intersection priority as shown in the building material editor, they will naturally cut through the weaker materials and thus connect with the concrete layer in the slab up here, but it will automatically cut through the insulation layer because it's weaker than the concrete.
So the only thing that's been added to this drawing is measurements and keynotes and the detail markers.
Yes, Exactly. And you just mentioned keynotes. And in this section, we have a lot of keynotes, so we don't need to describe all the elements in here. I'll just open my keynote palette to show the keynotes in this project. So here's my keynote database, my palette, where I can add or edit all the existing keynotes. I can add new folders and create new keynotes within these folders. So if I look at the floor slab, I have a few keynotes here, and I can simply say place label and add them to an object within my 3D model, whether that be the section vertically or horizontally. So it could also be on the plan drawing naturally. Now, in the keynote editor, the keynote is described as key 23.1. Down here, it has the key number, it has a title, and then the description that I will later have. I'll have the system add this description automatically to my layout, so I don't need to write all this myself every time. So I'll keep consistency within my project. So here's a keynote labeled on the strip foundation, on the inner wall, on the terrain layer, and on the partitioning layer as well. So if I go to the layout where this drawing has been placed, I can see the exact same section drawing now placed on a layout size as an A3, so ready to print as well, directly physically print or print it as a PDF. Now, in the bottom of the drawing, you can see all the keynotes that actually appears on this drawing. So this system will automatically add the legend that contains information about all the keynotes in this drawing. So in fact, if I were bold enough to delete this drawing, the legend will update because now there's no keynotes on the layout, and thus the legends will describe nothing. I'll just say undo and add the drawing again, and now all the keynotes.
Thank you. I thought we had to go through the backup system and show that also after deleting.
Not at all. The moment these legend parametric objects detect any keynotes within the graphic interpretation of the model on this layout, they'll automatically add the description that was added in the keynote manager.
So that's also a way of using and reusing data to limit the manual work on the project, that it automatically draws the section, it automatically shows the text that is placed with keynotes, so you only have to write the text once and it can be part of multiple drawings.
Yes, and whenever I add the keynote 13.1, for instance, the legend will come up with the same description, so it will always be the same as just mentioned. So I can use the same keynote in all my sections to describe the same building parts.
Perfect.
Now, as you might see in this section and in the 3D view, we have a constructional model of the entire load-bearing system in this project as well. It was already saved as a 3D view, so I'm just going to see if I can find that somewhere in my view map here. So you can see the load-bearing parts, both the steel project and the wooden project. However, I would rather like to see this model with some context, even though I have to relate to the load-bearing system right now. So I'm going to jump back to my previous view. This is my working view, but this is like a default starting view where I have a great overview of the entire project. Now, the way I'm looking at the project and working with the project is partly based on layer combinations. So all the elements will rest on a certain layer, and I can use the layers to turn on and off various building parts depending on what layer they are placed on. In that way, I can filter the model, and I actually have a whole range of different filters that can interpret the graphical, determine the graphical interpretation of my model. So right now I'm seeing pretty much everything. I could switch to a different predefined layer combination. I could adjust the detail level of all the parametric objects. I can add graphic overrides and add renovation filters and even different design proposals. So what I'll do now is I will create my own visual interpretation of the model. So I will select any of the walls. I will right click a wall and say hide layer. And now that layer will be turned off and everything placed on that layer will now be hidden. I'll then do the same with the roof. So if I get to select a roof somewhere, right click it and say layers, hide layer. So this is just a manual process that wasn't predefined. So just to show you how this could be done dynamically, I can see that one of the layers for the rafters for the roof has been turned off. So I'm simply gonna find that one and turn it on, so we can see the entire load-bearing structure. So here we have the rafters for the roof, and you can see how they have been, the design of the rafters and the construction of the roof has been designed in order to make room for the VELUX windows naturally. So this is all inside my 3D roof, and this is also what cuts through the insulation of the roof, as well as those wooden columns in the gable are those that we could see before would cut out a section of my insulation layer within my wall. That also means that the volume of the insulation will not be calculated where the column is placed, because, well, if there's a void, it will not be measured as volume for those components. That means that you'll get the right quantity takeoff.
So do you have to manually model these rafters and this complete wooden structure?
I could do that if I wanted to. I could also simply add a parametric 3D roof to my model with one or multiple roof planes. And once I have a parametric 3D roof, which could be constructed by a composite just as well as my walls, so I can determine the thickness of the roof and the thickness layers of all the building materials inside the roof, I could actually go to my roof wizard and have the program construct the entire wooden structure automatically based on a few rules that I'll set up determining the sizes of the rafters and the pillars inside the roof.
Clever.
Yeah, so it can actually generate this wooden structure automatically. It will also make the cutouts for windows and other elements within the roof. So yeah, all that could be done automatically.
And there's no rules for how detailed the model should be. So some people would like to model less and then draw more in 2D. But the reuse idea determines that the more you model, the more benefits you get. If you want to have quantity takeoffs of your rafters, they have to be modeled. If you want to automate the drawing material, then they have to be modeled. So you get a lot of benefits from doing this extra modeling work early on.
Yes, and the more you model in the 3D model or the 3D project, the more documentation you can actually draw from it. So no matter where I add a section line to create a sectional viewpoint of my model, it will look like the 3D model was constructed naturally. So in that way I can have consistency, and the more I model in 3D, the less I need to draw in 2D afterwards and keep updating whenever I change the design or anything has to be updated. Now, if I do it in 3D, it doesn't matter where I look at the model, it will look correct based on how it was modeled in 3D. So that's, of course, can be a huge time saver once it's done properly. Talking about layer combinations and all the elements that was added to this model, I'll just show a few other examples, and that could be the MEP system that we'll look into later on. But I'll just show you how these filters can actually work. So if I switch to MEP generic perspective, this is the same 3D project, but all the constructional parts has been shown with a graphical override that makes them transparent, and now only the MEP elements will stand out in their color to describe what system they belong to. But this is still the same 3D project. All the building parts have been grayed out or turned off or turned into a gray transparent shading.
And if you're going, oh, wait a minute, let's see more about this MEP model. Did you really model everything? We'll save this for next week's webinar, which will dive deeper into the structural model and the MEP systems.
Yes. So I'll just remove all the overrides and now I can see the wooden structure again. I could also add another layer combination or turn on another layer combination that would add even more layers to my 3D view. Let's just switch back to the previous initial 3D view that shows pretty much everything in the project. Within this project, we also have some details, of course. We could see that some of them were already labeled in the on the section drawing. But if I jump to the detail D06, which shows the detail of the built-in gutter, we can see how it has been constructed here. And in this case, most of the parts, well, first of all, the detail is based on a viewpoint in a 3D model. Let's just check where it comes from. So select detail marker in the source view. So the detail marker is placed on this section, and the section shows us the 3D model. So this is not a 2D model, it's a 2D interpretation of my 3D model. These are the 3D elements. I'm just cutting through them and looking at them from this vertical section line. So a marker has been placed, and that marker will generate a 2D section cutout of my 3D section, and now I can add even more documentation to it with my documentation tools. So I could keep measuring. I can add text and labels and even small fills. So a lot of details has been added to this viewpoint.
And even though it's a 2D drawing, so now everything is just 2D graphics on the detail, it's not only linked to the 3D model, but it's also produced from the 3D model when you start up. So it's really easy to add just the extra information you need to detail in scale 1 to 10 as it is here, where the 3D model will automatically make sections down to like 1 to 50. So it's really fast detailing when you have a 3D model that produces most of the work.
Yes. And of course, since this 2D detail is based on my section from my 3D model, I can always update it if needed. If anything changes in the 3D model, now I'm not going to do that now, but I could say rebuild from source view, and then it will redraw this section cutout of my 3D model if anything should have changed. If there was more insulation added to the roof construction or anything else has been changed, it will automatically update in this 2D viewpoint. Now this detail shows a cutout in 2D where a lot of extra detailing and documentation has been added. But we actually also created this as a 3D detail. So if I double click on this viewpoint, you'll see a rough cutout of the model showing the same area and the same situation, though as a 3D cutout, and that could be used for generating a 3D detail. Let me just show you how that will look in the end. So here is my 2D detail on a layout ready to print, and on the next layout I have the 3D detail showing the same situation. I just need to update based on the latest changes within the model. It's doing a small render.
So the small render is actually really nice to see, because that means it's live. So it's re-rendering the whole 3D detail, because if you change something in a 3D model, it will automatically also be added to this detail.
Exactly. So what we see here is actually a combination of different viewpoints. So if I open this viewpoint, you'll see a 3D document, which is a log perspective of the 3D model. It's a cutout of the 3D model. So these are all 3D elements that are actually in the model, and they have been given various graphical overrides and filters to make them look exactly like I want them to look in this situation. On the layout, there's also a rendering added underneath it. That is what took a couple of seconds just before, because it's rendering the exact same viewpoint. So all changes that happened since this drawing was updated will be added to it as well.
So there's different layers on the layout.
To reach this level of graphics, yes, there's actually 3 components on top of each other here combined to give it this graphical feel and vibe to it, which I actually think is pretty nice.
The third layer would be a gradient,
yes,
hiding the render with white from the bottom right.
And transparent in the other end, so it slides from wipes out everything with a white color that fades into invisibility, so you'll see what's actually underneath that fill, and that will be the 3D render.
So you still have to be a little bit creative to do details like this.
Yeah, but it looks nice in the end, right?
Exactly.
Just a oh, that is the one that will be rendered. That's not what I wanted to see. Sorry about that. the whole point is that this is also the actual 3D model that will be rendered, but there's been added a graphical interpretation that will turn on and off various propositions of the model. So in one of them, there's been made a cutout in the roof, and in the other one, the roof is complete. Yeah, so that is just to describe how this one was made. Yeah, I can actually see it here, even though it's in this white 3D document, but I can switch it back to the original model. So this is how we used to see it, and then this little graphical feature has been added to create another version where we've made some cutouts and a lot of different elements to show a more detailed 3D view of the roof.
And I really think it explains a lot about how this part of the building is put together. It can be difficult just to imagine from a 2D detail or from the visualizing model.
That was pretty much the technical walkthrough for this time, for my sake.
Perfect. So if you unshare your screen, then I'll jump back in, because I still prepared a little bit about detailing. So a really crucial part of BIM is the objects. And objects, they understand what they represent in the model. So a wall, understand it has an inside wall and an outside wall. A window is not a door. And that will make it possible for the 3D application to automate a lot of functionality. So we're really determined that we need good BIM objects to automate our workflow. And therefore we need the manufacturers to deliver product-specific BIM objects if we want to have really precise details of what is actually going to be built. And luckily for us, VELUX are probably the one manufacturer that has the most advanced BIM objects for ArchiCAD. And they really benefit the whole workflow of detailing your project. So just to sum up about these objects, it's a free download from VELUX. So if you use the URL in the bottom of the screen here, velux.com, healthy buildings, digital tools, BIM, then you'll be taken to a website where you can download these objects for Revit and ArchiCAD for free. Of course, we use the ArchiCAD version because this whole project development guide is done in ArchiCAD. And I think it's a good way of showing the really advanced parametric system that is inside BIM. So the whole idea of BIM is that you have one object and you can tailor it in different ways, switching different options on and off within the project. So I don't want to say too much about it. I would rather show it. So here I chose one window. I can select different sizes within the project library from VELUX. I can add more windows in one object if I want to. So this is two windows side by side. I can choose how to connect them. It could also be windows in another kind of grid. But in our project, we have chosen to just have one window placed at a time. I can choose a roofing material, so the details of the 3D model will be correct. I have a lot of choices about outside shutters and so on. I need to select the materials I want to use and the line types for the 2D drawings. And then there's a lot of extra information on the website. So for example, I can go directly from this window to the EPD to see the climate impact from this window. I could also choose to see the CE marking. So all the extra information online is linked inside the object. So I'm just going to go back and show a very advanced feature. So I can select VELUX Active, which is this system that has a lot of sensors inside the room that would automatically open and close a window if there's too much CO2 or too hot. So therefore I need to have the switches for this system, and they're also part of the BIM objects from VELUX. So I choose the right switch, and then I can also add it to my building. And for information, because I did this small change on my window schedule, I can now see that VELUX Active is now selected in this schedule.
That happened automatically?
That happened automatically.
Nice.
It's BIM. So these details, they are more advanced than you think. So every choice you do in the parametric objects will be, they will appear in the 3D model. And an example of this is this small insulation color that's added as an option around the window. If you choose to add that, it will add an extra cost of the window, but it will also change the U value of the product in a big way. So you'll save energy and you'll save CO2 for the lifespan of the window. But if you choose to have this option, if you want to save money, if you want to lower your carbon footprint, you also have to change the structure of the building to make room for this. So it's important that it's part of the drawing documentation, so the roof structure leaves room for a window with these features. Another part of detailing the windows are the connections between two windows. So even though I model the windows one by one, I still have connections that I can change. So I can choose what kind of connection, how far I want the distance to be between the windows, and if I want a rafter or just a cover. So I'm changing from the rafter to just a cover, and that will change directly in the model. And here you can see the next two windows, they are combined with linings for a wall, and the last two windows are connected by a rafter. So this is built into my 3D object, so I don't have to model everything by hand. To make sure all these really advanced details are displayed in the right way in my drawing documentation and in my 3D model for visualizing, I need to be able to switch it on and off. And if I had to do that manually, choose all my windows, change the detail level or the appearance, then it would take a lot of time. So VELUX has used a feature in ArchiCAD called Model View Options, where you can make these changes for different views. So for my early phase sketch drawing documentation, I can have a low detail window, and for my detailed views later on, I can add more details automatically. So the way this works is I open my model view options. I choose the pane with the windows, VELUX part. I can choose the country for the products and also the language displayed, and I can choose the level of detail. I can add I can show how much the windows will use of space when opened, and I can also turn on some helpers. And these small cones are helpers for modeling, because it can be a little bit tricky to figure out exactly how to place two windows if you want them to connect right. So if you turn on these helpers, it will be really easy to see if everything fits together. And then you question yourself, how am I supposed to figure out all these options within the objects? And luckily, VELUX also thought about that. So you can download an ArchiCAD file, which is actually the whole manual for the objects. So if you open that, you can just go through the different parts. And because it's an ArchiCAD file, you can also jump back out and see how these examples are made. And here you can see the section about the markers or the helpers, and how you're supposed to make sure that two windows connect in the right way in the drawing material. But
that manual that was just downloaded, the link for that download file was in the object inside.
Of course.
Yeah. Okay.
Of course. Okay. So you open up a window setting, for the VELUX objects, and then in the info pane in the bottom of all the settings, you're able to download a PDF of this if you just want to flip through it or print it. But if you want to have the original ArchiCAD file that created all these examples, so you can jump out in the 3D model and see how was this made, then you just download that also. So all the links are there together with the links for the EPD, the CE markings, installation instructions, and everything. So it's really complex, but it's also really amazing to work with a system where everything is just added in one place. So when we do the details, yes, the 3D objects can do details automatically. They will also change the details so it reflects the right kind of, now it's skylight, so it would be the right kind of roof construction and roof material. But to make sure that the objects are not too heavy and will slow down the model, there can be some examples that they can be a little bit rough. So often I would like to have a real CAD 2D drawing for my detail. But with a huge manufacturer like VELUX that have so many different types of windows and so many products, it can be difficult to figure out the right detail. So of course that's also built into the object. So I open up my object, I go to the resources tab, I go for my 2D detail drawings, and I put it to a website where I can choose the material for the roof, the exact type of window I want the detail for. It will ask me how I'm going to build that window into my roof and what kind of roof construction I actually have, if I have any add-ons, and then I get to download the PDF detail directly. And this detail is 1:5, so I just change my detail in ArchiCAD to 1:5 scale, and then I can just drag and drop the PDF from my downloads folder, and I can choose to explode it. So I choose it, right-click it, explode into current view, and now I can delete what I don't need from the detail, and I can actually change all lines and part of this detail and add it to a 1:5 detail in the project. I'm still going with the 1:10 right now, so I'm not going to add it directly, but I'm just going to show the workflow for this. And the last part of this journey about taking as much information and reusing it is of course the window schedules. So in BIM, window schedules are done automatically, and with the VELUX objects, there's actually also a schedule file that you can import into your project, because it can be a little bit complex to get an overview of all the information you can automatically draw from the objects. So in this example, there's a view of the window on top. It will tell you the exact type of window. If you want to pick it from the manufacturer's website at a later point, it will give you the height and the width. There will be a crossed out tick mark if it's VELUX active. You can see what kind of rafters there might be connecting to windows. And there's a lot of other detailed information about exactly what kind of product you're choosing. And in the bottom row, you can see that the quantity of windows is there. So there might be several windows of the same type, and they will not be displayed one by one, of course, but just with a quantity marker. So that part of the drawing documentation is also automated when you use a BIM system. And by using the manufacturer's objects, kind of digital products, you'll get some extra knowledge that would be difficult to find if I just used a generic roof window, skylight, and then manually entered all this. Yes, it should have windows active. It should be this type of window. To sum up our presentation today, I think it's important to talk about how you communicate the drawing documentation. Some time ago, you would do physical printed drawings, And of course, that's still a big part of being on a building site, that people walk around with physical drawings. But drawings should be updated throughout the building process. And sometimes you don't have access to the latest drawing, you didn't get to print it, or you didn't know there was a new drawing that you should print. So there are benefits of having a digital building site where you access drawings directly on a screen. But it could also be for the building owner who wants to understand the project, the future users, or whoever need to see the project before it's built. So we are obviously promoting BIMX, that we think is the perfect BIM viewer. It's really easy and therefore also cheap to use for the consultant. It's a one-click export. It will automatically upload. And there's a free storage site connected to your ArchiCAD subscription where these models will be stored. And it's also free for the end users, so they can download a free app. The apps are made specifically for iOS and Android, for Mac and Windows. And there's also a web app that might not be the fastest way to, and the most fluent way to see the content of your project, but it's really easy because it works directly from a website. So if you want to see the model that we have done, you can go to velux.com/project-development-guide, and there's a link to the BIMX project. And I always suggest that you use an iPad because that's the best user experience. The smartphone will do the same trick, but it's just a smaller screen, so you don't see drawings in the same way. You can flip through drawings. You can always use the section markers to jump directly to a section. And if you want to, you can actually see the section in 3D with a small 3D tab. It will place the 2D drawing in the 3D world. You can turn it off if you want to. And you can change where you cut the model if you want to explore the model more thoroughly. And if you walk into the model, there's a small guide, so you use a joystick on screen to walk around. You can move through windows and doors, and you can move up stairs out of a staircase. And if there's a drawing marker in the 3D space, you can jump back out to the 2D drawing material and flip through that. So I hope you'll go to the VELUX website and find the link to the BIMX project, so you can see what we think is the absolute best way to communicate your project to building owners, future users, and the contractors on the building site.
You just mentioned that it should be downloaded to an iPad, but it could be any tablet, right?
Also works on Android tablets and smartphones of any size and type. And that's what I prefer, because this way of using your finger directly on the screen is just an amazing way to understand the project and to see what BIM is all about. If you tap on a window, you can see the information. There's actually a small ruler, so you can make measurements directly in the model. And on a smartphone or an Android tablet or an iPad, it really works well. There's also a Mac and Windows app, and they also work well, but I think that's more focused on gamers. So you use your mouse and keyboard to move through the project. And if you're a gamer, that's amazing. If you're a normal person, I think it's a little bit more difficult.
Then you just have to get used to it.
Exactly.
But the point is that the viewer is actually for free, so anybody can download it to whatever device they like and walk through the digital tour of the 3D model from the VELUX project.
Exactly.
And ArchiCAD creates such a model from any project, in fact.
Yes, I think that's actually the strongest point and the most important point for BIMX, that there's no login and there's no password. So you don't have to have an account as a user. As a consultant, you just send them the link, they download the app and the project, and they're ready to go. No barriers creating an account and trying to make it work and being accepted by it just works.
And actually, if you get the model via a link, then if the consultant does any changes and update it, you will actually get a notification on your mobile device that does an update to this model.
Exactly.
If you're on the building side and actually were to produce this project.
Yeah, there's a lot of benefits for going from printed paper to a digital communications tool like BIMX. So just to sum up about what we've been through today, it really makes sense to use the BIM tools to model into detail. The more details you add, the more benefit you get later on. It's up to you to find the sweet spot for your project and your office when it makes sense to model more and get the benefits of the added data, or when it makes sense to model less and add more in 2D manually. It makes sense to use the 3D model as a prototype, coordinating between different stakeholders, so you're sure that what you actually have drawn is what is possible and what the building owner wants you to build. And if you want to communicate that, you can communicate with BIMX, as we just showed you, but also these 3D prints. And because you have all the information, the geometry there before, it doesn't take much work to change it to a 3D print. And I actually have it right here. So I think I'm gonna stop sharing my screen. And you can see here, there's a 3D model. It's really detailed, and it's possible to take off parts of it. So I can look down into the model and also take away the next level and see the model. It's a really nice way of understanding a project. It's really tactile and intuitive, but I think that the cost of making a real building is so high. So giving away a small physical model for the years that the building owner is waiting for for the project to be a real project, I think also has a huge value. So that's what we wanted to talk about today. I don't know if there's any questions from the audience.
There's a question about the libraries from the download file, and of course, if anything should be missing, we will fix it right away.
Yes, and depending on, yes, we just made a new version of the project material, and hopefully that will be on the VELUX website soon. So if there's any mistakes or problems with the library parts, it should be fixed. This is a work in progress. Next week we're gonna show the MEP and the structural project. The week after we're gonna talk about the LCA information, and we'll be updating the information throughout. Is that the only question?
Yes, so far.
Yes. I just want to go back and share my screen. We have the link for the next webinar, and you can go to LinkedIn and you can sign up. Structural and MEP, hybrid ventilation design. I think it's really interesting to see how these more advanced systems can really take advantage of a BIM workflow. So I hope to see you again soon here. Thank you, Thomas, for showing us everything live. That's amazing.
Thank you.
And thanks to Lorena and Alberta for being on the back end and making things work. And go to LinkedIn, go to the VELUX website, the VELUX page on LinkedIn, and sign up for the webinar next week. See you soon.